So today we're covering two very key concepts that's going to be used a lot in terms of fraction calculation and fraction simplification. So the first one is called your greatest common divisor or factor, and the other one is called your least common multiple. So if we have a number 40, we're thinking about what can it be divided by that will leave us with no decimal. An example of this would be 8. That will give us 5. So this will make 8 and 5 both a divisor or a factor of 40. As you can imagine, if 40 is divided by 5, you'll also get 8. So no decimals as a outcome. If we use a number like 12 to divide 40 by, we will get a decimal, 3.333. And that means this is not a divisor or a factor. So basically it's saying that if A is divided by B, and both A and B are integers, which means they're whole number, like 0, 1, 2, or negatives, like -1, -2, yada yada yada. But you get the idea. So if both of these are integers and divided by each other and they get an integer, and it gets C, and then C is integer, and that means both B and C are a factor of A. Now we understood the idea of divisor and factor, let's look at what a common divisor and factor is. So if you think about common, it means something that everyone has. So when it comes to common divisor or factor, it really involves two or more numbers. Let's say if I have 12 and 15. The first thing we can do is we can list out all the factors that I have. Right? So everything will have 1 and the number itself as a divisor. So 1, 12, 2, 6, 3, and then 4. 1, 15, 3, 5. All of these numbers listed is the divisor or the factor of 12, and all of these numbers listed are factors of 15. If we look at the common factor of 12 and 15, we'll have 1 and 3. So that's our range to choose from. Greatest just means it's the biggest of them all. So the greatest common factor of 12 and 15 is 3. So now let's look at some larger numbers. So I have 164 here, and then 232, 4, 16, and then 8 and 8. That just leaves us with just 8. On the other side, let's have 148, 2, 24, 3, 16, 6, and 8. So if we list out the common factors, there's going to be 1, 2, 8, 16. And the greatest common factor of them all is 16. Hope that makes sense. And now let's move on to the least common multiple. The common multiple is essentially thinking about the possibility of what a number can become if it gets multiplied by an integer. Let's say if I have 3, and we think about the multiple that I can have. We can times 2, and that gives 6. Times 3 gives me 9. Times 4 gives me 12. So all three of these are multiples of 3. So you can see this list can essentially just go on and on and on forever. And let's pick another number, such as 4. So 4 times 2, that's 8. Times 3, 12. And then times 4, that is 16. Right, so same thing. These are multiples of 4. And then this list can go down forever as well. So common multiple, again, right? It comes to common. So common possessed by everyone. So possessed by both numbers. So it's got to be a multiple that appears for both numbers, right? So in this instance, we have 12 in our multiple list from 3, and we have 12 here from the 4 list. So 12 is one of the common multiple of 3 and 4. And if we keep thinking about what other common multiple 3 and 4 have, right? There's going to be infinite amount, because we can just keep doubling or tripling or times 12 by another integer. So if we think about doubling it, right, 24. Right, 24 is a multiple of 3 if you times it by 8, and it's a multiple of 4 if we times it by 6, right? If we triple, right, if we times 12 by 3, we'll have 36, right? That's 3 times 12, that is 9 here, right? So again, this list will go on forever and ever and ever. So what we're most interested about is what is the least it can be, the smallest number that we can possibly find, which is 12 in this case. So in this example here, right, it's pretty straightforward because all you have to do is times 3 and 4 together, right? You might have noticed. Of course, if you multiply the two numbers that we're interested in together, we will find a multiple of both numbers. But let's look at a slightly different example. So if I have 12 and 16 here, right? 12 times 2 is 24, times 3, 36, times 4 is 48, right? Times 5 is 60. And over here we times 2, 32 times 3, 48, times 4, 64. So you might have noticed we haven't quite gone down to 12 times 16, right, which is 192. And over here we haven't quite got to 16 times 12, which you can expect will also be 192. Because, why do we stop? Because we already have a common factor before we got down to the two numbers multiplying them by themselves. So in another word, right, the common multiple has many, right? But the least common multiple that we're interested in is 48 in this case. So here's a little trick. If you're finding the least common multiple of non-prime numbers, so you might have heard me say prime number. So if you don't know what it is, it's essentially numbers like 1, 2, 3, 5, 7, 11, the list go on forever, but these numbers can only be divided by 1 and itself, right? So if you think about what's missing here, 4, right? Because 4 can also be divided by 2. We're missing 8, 8 can be divided by 2 and 4, and then we're missing 9, that can be divided by 3, we're missing 10, that can be divided by 5 and 2. So these numbers essentially have more factors other than 1 and itself. So coming back to here, right? Every single of these multiple is composed of many different factors. So this trick is essentially look at 12 and 16 and think about what is the greatest common factor that we have. So you might be thinking, oh, this is going to take too much time. Do I really have to do this every single time when I come across this? And trust me, this process gets a lot easier the more familiar you get with these numbers. If we look at the greatest common factor that we have here between 12 and 16, it's 4. So that's where we're going to start on. Instead of seeing 12 as a 12, we're going to see it as 4 times 3. And instead of seeing 16 as 16, we're going to see it as 4 times 4. So as we sort of mentioned above, right, the easiest way to find the multiple between two numbers is just to multiply them together. But you get this ridiculously large number sometimes that's not helpful in terms of finding the least common multiple. So if we break it down this way, right, we already know that 4 is a factor of these two numbers, and they are common, they're shared between the two. And the only differences that we have is this extra bit. So this extra bit is the only bit that we have to address. So if we need to find the common factor between 12 and 16, we just leave the 4 alone, and we leave the common factor alone, and we just multiply the remaining parts together. 3 times 4, and that's how we get 48. Okay, let's look at a slightly different example. Let's do 45 and then 99. So very big numbers, and if we just do 45 times 99, yes, we will get a common multiple, but it will be this ridiculously large number. And let's try the approach that we tried before. If we look at the numbers here, they do have 9 as the greatest common factor. So instead of seeing 45 as 45, now we're going to see it as 9 times 5, and then 99 is 9 times 11. So to find the least common multiple, we'll now leave our greatest common factor alone, which is 9 times 5 times 11, just multiplies the remaining part, and that is our least common multiple, 495.